It's Rob. Welcome to the last episode of the season. It's getting to be close to summer. If you put this picture up next to some of my other videos, you'll probably notice a lot more redness. Although it's not as bad as it used to be. You know, the seasons just changed so fast. I kind of forgot about sunblock. But you know, vitamin D that you get from the sun keeps away the crazy. So, if it's sun, it's fun. I'm going to go get some. So, I am also changing out my clothes, and I realized I got a lot of Hoosick Valley shirts that are really similar. But when it comes to Hoosick Valley shirts or sports shirts, I have a really hard time getting rid of them. So I have a little bit of a hoarding issue. You should see my collection. I'm going to go show you some of them. And what I do is I change them out from the winter stuff, which I'm literally like doing right now, to the summer stuff. And I was thinking to myself, look at all these Hoosick Valley shirts I have. A lot of them are obviously very similar. Truth be told, I got rid of most of my dodgeball shirts. I think this is my only dodgeball shirt that I have left. I think I might have done like 5 dodgeballs. And you know what? You don't really need a lot of the same stuff. What's the whole point of that? But this is like one of my problems where I do have a little bit of a hoarding issue. I have a hard time getting rid of this stuff. It's like such a memory for me. I legit still have stuff from high school, especially if it's got my name on the back. Oh, gotta love it when my name's on the back. So a lot of these shirts are similar. Look at them. What's similar about them? Well, they all say Hoosick Valley. Okay, so that one says HV. A lot of them say faculty. All of them have, oh, no, this one doesn't. All of them except this one have a ball on it. 2 of these shirts are the same, not similar. I have 2 of the exact same HV basketball faculty shirts. We must have used the same ones 2 years in a row. And this one over here is not as similar as the other ones because it's black. It was totally my favorite. You probably can't tell because it's so faded and I just can't get rid of it. It is, we had a basketball game around Halloween. So this is like a skeleton dude with his head exploding. Okay, I'm not normally dark. Dark stuff isn't what I'm into. But this shirt's just so unique that I like it. So in any event, this lesson is about similarity. So we're going to not be doing a lesson on t-shirts, but we will be doing on similarity. Like all of these shirts have blue in common, except for that one. They have Hoosick Valley in common. They have a sport in common. They're not all the same. There's only 2 of them that are the same. Every last thing about them is equal. The ones that are similar just have some things that are equal, like color or words. We're not going to be doing t-shirts. We're going to be doing a lesson with similar triangles. See you in a sec. Hey, let's talk about some similar triangles. I am going to put in the Google Classroom some links to some more GeoGebra, some real cool software that you can use to mess around with triangles and see what happens, especially if they're similar. So I'm just going to go over here and play around. And I have more than one link. I'm not going to spend time going over every link, but you should check it out. I don't want to make my video too long. So these triangles are similar. Similar as in they're not exactly the same, but some things are the same. So if you look at this, let's see, what do you notice that is the same? No. Okay, so this angle is the same. The green angles match, they're the same, and the red angles are the same. The sides aren't the same. If the sides were exactly the same length, then with all the same angles, then we'd be talking about equal or congruent triangles. These are just similar. So I am changing the sides on this, but the angles aren't changing because that's the way it was designed. It was designed to keep the angles the same. So if I move this angle, the other one matches it. To keep these triangles similar, these are similar triangles. Similar triangles will have the same angles, but not the same sides. And
It's basically, you're basically looking at, one triangle smaller or larger than the other one. Meaning it could be rotated. So let me see here. If I can make this come down here. So now they're kind of oriented the same way. And if I shrink this, let's see. Shrink this one, it won't move. Well, that one doesn't have a gray dot on it. This one has a gray dot on it. So, right, almost there. Look, these are exactly the same. Right? Oh no, it was pretty close. That says 4.9, that says 5.1. Let's see if I can get it to match. There we go. These are the same. So when I go and I stretch this, that's exactly what I'm doing. I'm stretching it. It has the same angles, has the same shape. It's just the sides are longer or the sides are shorter. If you notice, there's a ratio here. So the things that I want you to realize when you're doing these is which angles are the same. This is angle A, or I can call it angle CAB. This is angle K, or I can call it RKL or LKR. But you need to know how to really name your sides. That's the important part here. With this beautiful drawing, they showed you which sides match or correspond. The red sides match, so AC matches KR. Now, I want to say it in the same order. I want to say A to C matches K to R because the A and K are equal angles. The C and R are equal angles. So you really want to name it the same. So when they match, you're getting a proportional relationship. The blue sides match, and that says BC. So to label it in the same order with the same equal angles, it would go LR. Okay, so you got this to play around with. So again, this is kind of like in the chapter when we did scale factor. We've done these things before. Okay, it doesn't matter how I turn it. You just have to remember which angles were the ones that matched, and then name the sides according to that. So I don't care how I spin it. So name it in the order the angles match. And all the sides are proportional. Right now they say they're 1 because they're equal. The ratio is 1. If I shrink it, then from AB to KL, where's AB? Here's AB compared to KL is 1.9. We're going to do some examples now. This is in your packet. I gave you way more examples than you need. We're not going to do them all, but if you wanted to do extra, good for you. I have extra for you. So let's check out this example and see if we can apply all this knowledge. The thing I'm going to go over that is newer and you really need to get used to, especially when you're going to do more math in your future, is all the notation. So this says in the diagram below, you have triangle A, B, C, and you have triangle A prime, B prime, C prime. So you need to understand that this right here, those little dashes, mean you say the word prime. And it means the image. That's like, when I slide the triangle bigger and smaller, if I move point A to a new spot, I'm going to call it A prime because they're related. And so B goes to B prime and C goes to C prime. So in the other example, the letters weren't the same. So you have to think a little harder of which ones match. But here, angle A, 59 degrees, matches with angle A prime, 59 degrees. So they made your life really easy. Segments have to be named with 2 letters. That's how you name a segment. And you should remember what these bars mean. These bars means absolute value. Absolute value is the distance something is from 0, and distance is never negative. So they labeled this very accurately with absolute value because it's distance. So I want to know, based on this information, that these things are similar. This is the symbol for similar. So, excuse me, just had a little minion under the table there. Had to shoo away. So these triangles are similar. because you have to have 3 congruent angles. Now, I don't see the third angle labeled, but what's the deal with the angles in a triangle? They have to sum to 180. So if these two sum to the same number, then doesn't the third one have to add up? If it has to add up to 180, then the third number has to be the same. So based on this information, are these similar? 2 of these angles, this is my angle symbol, are congruent or equal. They're actually equal because I know the numbers. So I should just put equal. So the third angle has to be equal also because it sums to 180. So we call that angle similarity. That's a theorem. If 2 angles are the same, then the triangles are similar because the third angle has to be the same. So knowing now that these things are similar, the little squiggly mark, determine the length of side A prime, C prime. Now you have to figure out which sides match, and you've done this before. It looks way more technical because I'm using more letters and primes and stuff, but you've totally done proportional stuff before, especially when we did the whole scale factor unit. So I want, which side do I want? A prime, C prime. So that would be this side right here. I don't know it, so let's call it X. Which side does X match with on the other triangle? A prime, C prime is going to match with the matching letters A, C. So it matches with this side right here, which is 6.1. And now I need some other ratio in order to solve this, to finish my proportion. So you have to find 2 other matching sides and write down their numbers. So if I did C prime, B prime, do I have CB in the other triangle? Let me change my colors. This is C prime, B prime, CB over here. I don't have any information, so I'm not going to use that. So this is why I'm using Cami. I'm using Cami because I can do the colors. So AB prime is going to match with side AB. And which one did I do first? Big triangle first? I did big triangle first. X is to little triangle 6.1. So big triangle green side match with little triangle green side. Okay, I have to keep my order the same. So I'm going to put a B for big triangle here and L for little triangle there to try and understand the order I was doing that in. And then once you have the proportion written, it's easy peasy lemon squeezy. We're going to do our cross multiplying. And we're going to multiply the both sides. And I'm going to get 31.232. And then I'm going to divide by the coefficient to get my answer of, and then we're going to check to make sure if it makes sense, 9.76. Now, is this my big triangle? Yeah, it is. That makes sense. 9.76. Okay. And then it says, let's do BC. Now, because I already used the letter X, I don't want to use the letter X again. So I'm going to go back up to my picture. BC. I'm going to call it Y. This side matches with the other B prime, C prime side, which was right here. And then I don't want to use my answer from part B in case it was wrong. So let's go back and use the ratio we just did that was in green, my green ratio. Remember, I went big to little, so let's just stick with that. The big triangle in yellow was 8.96. It matches with the yellow side on the small triangle with the same kind of letters, which is labeled Y. And then back to my green ratio. Where'd my green color go? No, I'll just use this one. Okay. There it is. 5.12 from the big one, 3.2 from the small one. And again, you're going to do all your cross multiplying and stuff. Because my fingers are kind of wide, I can't fit all the work. So you cross multiply, you get 5.12 times y equals 8.96 times 3.2. I'm going to divide by the coefficient of 5.12. And side BC, which was my letter y, is 5.6. Okay, and remember, if you don't get any of this, we can do it during Google Meet. But I'm going to leave this here in color, so hopefully it is easy to see what's going on. I don't want you to skip this work. You want to show all this work. So the whole point is triangles are similar if they have 3 congruent angles, 3 angles that are the same size. If you know 2 angles are the same, you know the third one has to be the same because they all add up to 180 all the time. A triangle's angles have to add up to 180 degrees. Then you have to figure out, because of the matching angles, which ones are the matching sides. So if angle A matches angle A prime and angle B matches angle B prime, then the sides AB and A prime B prime are going to correspond. They're not going to be equal, but they're going to be proportional, because it's just like doing the whole scale factor unit. It's just taking one triangle, I'm flipping it around any way I feel like it, and I'm shrinking it, which is this way, or enlarging it. And again, I'll be on a Google Meet if you need me. So play around with my GeoGebra links. Call me if you need me. Let me see.